Hello.
Hello. Hello. What's this video about?
This video is about hydrocarbons.
Oh, and what will you talk about?
We are going to talk about how to name and draw structural formulas for hydrocarbons.
What's your group?
220.
220. And what's the members of your group? Which are?
Ericl, Lopez, Makalani, Becerra, Mariana, Caballero, Natalia, Garcia, and myself, Edgar, Silva.
And most importantly, what is your teacher's name?
The greatest teacher of all time, Miss Valeria Verdaguer.
I have heard that she's a very good teacher. Okay, and what's the due date?
The due date is for May 21st of 2014.
Okay, just recall it, she's a very good teacher.
Best.
Hi, my name is Natalia, and the objectives of this tutorial are to show you how to write the UPAC names for hydrocarbons and how to draw their structural formulas. The UPAC is the International Union of Pure and Applied Chemistry. It serves to advance the worldwide aspects of chemical sciences and to contribute to the application of chemistry in the service of humankind. UPAC can address many global issues involving the chemistry sciences. UPAC is best known for its work standardizing nomenclature in chemistry, and it was established in 1919. As we know, there is an importance of having defined rules for hydrocarbons, because if we don't have rules for defining them and naming them, people will name them as they want to, so we have to have some special rules for them to be named. And there are many hydrocarbons, as we know, like methane, butane, propane. There are many hydrocarbons that we use in our daily life, and hydrocarbons are the compounds composed of carbon and hydrogen. These carbon atoms have four bonds. They can be saturated with one single bond, unsaturated with one double or triple bonds, acyclic with no rings, and cyclic with rings. And they can be classified as alkanes, which have single bonds, alkenes, which have double bonds, at least one double bond, alkynes, which have at least one triple bond, and aromatic hydrocarbons that contain benzene rings.
Good day. Today I'm going to show you how to name alkanes. First, we must know what an alkane is. An alkane is an hydrocarbon with single bonds, as you can appreciate here in all our exercises. First, to name alkanes, we must determine the longest chain, and to check out if they are alkanes or alkenes or other type of hydrocarbons. Then we check the aim, which is the termination of the alkane. Then we name the carbons, we number the carbons, and identify the alkyl groups and write the name at the end. So, let's do this. We see that it is an alkane because it has only single bonds, and we identify the main chain, and we number the carbons. 1, 2, 3, 4, 5, and 6. So, then we identify the alkyl groups. Since we have already done that, we know that this is an hexane, and that we have only methyls, and we have them in the carbon number 2. So we have 2, 2, then we have another methyl here in number 5. We put 3 methyl because we have 3 methyls. 3 methyl. We put a comma here. Just erase the name. We put hexane. Now, this is the final name. We continue with this one. We know that it is an alkane because it has only single bonds. Then we identify the main chain. Then we number them. 1, 2, 3, and 4. We identify the alkyl groups. 1, 2, 3 alkyl groups. So 3 methyl. We have 1, 2, 3, 4. So we have here a butane. We have a butane. Okay? We have 2, 2, 3, 3, trimethyl, butane, and that's the final name. We continue with this one. We identify that it is an alkane because it has only single bonds. We identify the main chain, the alkyl groups, and we name them. We number them. 2, 3, 4, and 5. So 1, 2, 3, 4, 5, and we have a trimethyl because 1, 2, 3, trimethyl, 3. Okay. So we have a 2, 4, trimethyl, comma 5. It is not a butane.
Pentane.
It is a pentane. Well done. And that's the final name.
Okay, so the steps for drawing a structural formula for alkanes are very simple. Imagine you have 3 methylpentane. First you have to draw the parent chain. You know the parent chain starts with a pentane, so you need to draw 5 carbons. Then you need to see that in the number 3 there is an alkyl group named methyl. So you number the carbons, and in the number 3 you add a methyl. Then after that you need to saturate the chain you before had with hydrogen. After that you only condense the formula and it should look something like that.
Doctor.
Hi. Okay, so regarding our previous knowledge, we know how to name alkanes. So for example, we have the 2,2-dimethylbutane. How do you draw it? Well, you draw the parent chain. In this case, it's a butane, so you draw 4 carbons. After that, you know the numbers and put the alkyl groups in its place. So you know that in the number 2, you have 2 methyls, so you add them. After that, you need to saturate the chain and just condensate the formula, and it will look something like that. Another example would be the 3-ethylpentane. Again, you draw the parent formula, 1, 2, 3, 4, 5 carbons. You know, you need to look at what place would you place the alkyl group and place the ethyl group in here, in the number 3. After that, you saturate the formula and you condensate the formula, and it will look something like this.
Hi, my name is Mariana Caballero, and I'm going to talk about alkenes and how to name them and how to draw the structural formula, and I'll give examples for both. First of all, alkenes are hydrocarbons which only contain hydrogen and carbon and have at least 1 double bond. And to name alkenes, we need to follow 5 simple steps. The first one is analyze the chain, then find the longest chain of carbons, then number each carbon, find the double bond, and then the suffix in. Examples for naming alkenes are these two. We'll start with this one. First, we need to analyze the chain so that we can know that we are working with an alkene. Now we need to find the longest carbon chain. This is the whole chain because it's the only chain we have. And now we need to number each carbon, starting from the one closer to the double bond. It could be the same on both sides. We'll number from left to right. We have 4 carbons. And we need to find the double bond. The double bond is in carbon number 2. And with this information, we're ready to name our bond. And we have a 2 because it's where the double bond is found, in the atom of carbon number 2. Next, the hyphen. And we have a team because we have 4 carbon atoms. And in is the suffix for every alkene. Now with the next example, we have a similar chain, and we need to follow the same steps. We first analyze the chain, and notice that we have a double bond. This means we're working with alkenes. Now we need to find the longest chain, which is the whole chain, and now we'll number from the atom closer to the double bond, which is as the same as the previous example from left to right. We have 1, 2, 3, 4 carbon atoms. And now we need to find the double bond, which is here in carbon number 1. And we're ready to name our chain. As the double bond is in with carbon number 1, we don't need to put 1. So we'll just write routine because we have 4 carbons, and the suffix "-ene is for every alkene chain. Next, I will show you how to draw the structural formula for alkenes. We need to follow only 3 simple steps. The first one is draw the carbon chain, then we attach all the branches to the carbon chain, and then we add the hydrogens to fill each carbon bond. And we have 2 examples. The first one is 2-octene. We start with this name. And with "-ene", you'll know that we are working with an alkene, so we have at least 1 double bond. And "-eth" is for 7 carbons, so you start drawing the carbon chain, which we already did. We have 1, 2, 3, 4, 5, 6, and 7 carbons. Now the 2 will tell you where the double bond is. We have it in the atom number 2, here, so you will just, instead of writing a single bond, you will write 2 hyphens. And, well, we already have the carbons, the double bond, and now we only need to fill in the bonds remaining with hydrogens. Here we know we use 3 hydrogens because we have 3 bonds left. Here we only have 2 because we have here a double bond, now this one, and here we go the 4th hydrogen. Here is the same. Here we only need 2 because we have single bonds on each side. So the hydrogens will go here. And it's the same for it. 2 hydrogens here, 2 hydrogens here. And here we will have 3 because we have 3 bonds available. Now the next example, we're working with 2-octene. We have the bond in the 2nd carbon. And this is for 4 carbons. And here we know we're working with alkenes. So we first write all the carbons. We're working with 4. We have 1, 2, 3, and 4 carbons. Now we know the double bond is in the carbon number 2. So instead of writing the single bonds we did here, we'll write the double bond and then the 3rd single bond. And now we'll fill in the spaces remaining with hydrogens. Here we would have 3 remaining spaces, which would be these 3. Here we would have only 1, because we already have 2 bonds here, and we have another one here. So we write this hydrogen beside that carbon. Now here we have 2 bonds. We have the 3rd one, and we only need the 4th one, which will be this one. And here we have 3 spaces left. So we will write 3 hydrogens. And that's how to draw the structural formula for alkenes. Now I'm going to show you what alkynes are and how to name alkanes and to draw the structural formula for them. First, alkynes are hydrocarbons containing only hydrogen and carbons and at least 1 or more triple bonds. To name alkynes, we need to first analyze a chain, then look for the longest chain of carbons, then number each carbon starting from the carbon that is closer to the triple bond. Now we will find the triple bond and we add the suffix "-ine" because we're working with alkynes. Now the examples for naming the chains, we have these 2. And we start with this chain, and we know it's propyne because we have 3 carbons. And we know we finish with "-ine" because we have a triple bond. But first we need to analyze the chain. So find the triple bond. We know we're working with an alkyne. Now we need to find the longest carbon chain. It's the whole chain. carbon number 2 and carbon number 3. This will be 1 because the chain is here. And now we look for the triple bond. We have the carbon number 1. And now with the suffix "-ine" for alkynes, we can start naming our chain. We will have 1 propyne because we have 3 carbons, and "-ine" because we're working with alkynes. But when we have the number 1, we don't need to include it. So that's the with the last example, we need to analyze the chain. So we know that we're working with an alkyne. Now we need to look for the longest chain, which is the whole chain. And now we can start numbering each carbon, starting from the one closer to the triple bond. So we start from left to right. We have carbon 1, 2, 3, and 4. With this, we know we're working with butane because we have 4 carbons. This tells us that we're working with 4 carbons, and this that we're working with an alkyne. So we already have the name, but we need to know the number in which our triple bond is found. So with the numbered carbons, we know we have a triple bond in the second carbon. So we add the number 2, the slash, and the time. And now I'm going to show you how to draw the structural formula for alkynes. First, we need to follow these steps that are draw the carbon chain, attach all the branches, and add all the hydrogens to fill each carbon bond. We have 2 examples. The first one is 2-butane. With this, we know we're working with a 4 carbon chain and an alkyne. So we first put the 4 carbons, and well, the triple bond will be in the place according to the number we have beside the name. So now we have the carbons. We have 4 carbons. We have the triple chain in the carbon number 2, starting from left to right. We have 1, 2. Here's where we have the triple bond. And we add all the branches. And finally, we need to fill in all the carbon bonds with hydrogens. Here we know we have 3 hydrogens because we have 1, 2, and 3 remaining bonds. Here we have no hydrogen because we already used the 4 bonds that carbon can have. It's the same with this carbon, and with this carbon we also have 3, 1, 2, and 3 bonds left. The last example is 2,4 pentadiene, and with penta we know we're working with a 5 carbon chain, so we start drawing the carbons, starting with carbon 1, 2, 3, 4, and 5. With this, the die tells us we have 2 triple bonds. And the numbers tell us where the triple bonds are found. We have the first bond in the carbon number 2. We have number 1, number 2. We have the triple bond in here. And the second bond we have in carbon number 4, which is number 3 and 4. We have the triple bond in carbon 4. And now that we have all our bonds, we have a single, a triple, a single, and a triple. And we can start drawing our hydrogens. We have 3 hydrogens in the first carbon because we have 3 bonds left. We have no hydrogens in this carbon because all the 4 bonds are being used. And the same with this carbon and with this carbon. And with the last carbon, we have only 1 hydrogen because we're using already 3 bonds in here. And we have only 1 bond remaining. And that's how you can draw structural formulas for alkynes.
Aromatic compounds are organic molecules containing a benzene ring. If you don't know what a benzene ring, it looks something like this, right? So, I'm going to teach you how to name aromatic compounds. So the steps, we're going to use them in the examples. First, you need to identify each of the alkyl groups. So we have like double bonds. The double lines mean double bonds. So yeah. For example, in this example, we're going to start numbering clockwise motion. 1, 2, 3, 4, 5, 6. So, bromo and chlorine, maybe it's going to look something like 1, bromo, hyphen, 2, hyphen, chloro, hyphen, benzene. Now I'm going to teach you how to draw the structural formula for benzenes. In this example, we have a name which is 2 hyphen bromo hyphen 4 hyphen ethyl hyphen 1 hyphen methyl benzene. So first you need to draw the benzene structure that looks something like this. Then you go in order like 2 bromo, and you're gonna find in the carbon number 2 a bromine. Then for ethyl 1, 2, 3, 4, and you're gonna draw an ethyl. And then in the carbon number 1, you're gonna draw a methyl, and benzene. It already shows that you're working with a benzene. In this other example, we have 4 bromo, 1 ethyl, 1 methyl benzene. So we start again with the benzene structure. Then we look like 4 bromo, like 1, 2, 3, 4. And here you're gonna have a bromine. Then 1 ethyl. Here you're gonna have an ethyl, CH2, CH3, 1 methyl, and you're going to add another branch in the number 1 carbon with a methyl, benzene. And that's it for the class of today.
Here we can see a table in which we include the main structure for the functional groups related to the hydrocarbon derivatives, and we include also 2 examples for each one of them.
A hydrocarbon derivative
Doctor.
is any hydrocarbon that has another element attached to it, but it's not hydrogen. One example is alcohol. Alcohol distinguishes itself by the OH group attached to the end of the chain. Another example is ketone. A ketone distinguishes itself by the double bond O attached in the middle of the chain. This is acetone, an example of a ketone. All ketones end with -one.